Okay, hi guys, let's solve this paper together. It's an engineering mathematics 1 paper. Okay, the sinusoid of the voltage in an alternating current AC circuit at any time is given by this V function f of t. Okay, in volts, determine the following. Okay, number A, we have to determine amplitude. Amplitude equal 10 volts. From this information you can see the amplitude equal 10 volts. Okay, number B, okay, phase angle. Okay, phase angle equal minus pi over 3 radians. Okay, they did not add phase shift, we can just calculate it here. Phase shift equal minus pi over 3 divided by 4 pi. Okay, you can see 4 pi is this one, minus pi over 3 is this one. So if you have something like A cos kt, okay, then let's say plus alpha. Okay, if you have something like this, okay, you know that your phase shift should be alpha minus alpha over k. This is the formula, right, for phase shift. Okay, let's continue. Then from here you will have 1 over 12. Then your answer, it will become 1 over 12, which is 0.083 seconds. Okay, because remember on that waveform, here it's seconds, here is voltage, so the shift will occur along this t-axis. Okay, then let's continue. Number C, they want period. This is a cosine function. Then you will say your period t equal, you can say period equal, or you can say t equal 2 pi. Here the information here is given in radians, 2 pi over 4 pi. You can go back here, like we said, you always look at the value coefficient of t, which is k. The reason we choose 2 pi, this thing is a cosine function. A cosine function period is 2 pi, or you can say the rest is degrees when you work with degrees. Okay, then here your period will be 0.5 seconds. Okay, then number D, they ask us to solve a frequency here, frequency. Okay, then frequency is f equal 1 over t. Then you substitute the value of t that you just solved above, which is 0.5. Then your answer here will be what you do your maths, or you can use a calculator, but you know your answer here will be 2 hertz. Okay, then let's continue. Number E, they want a mean value. Mean value, when you work with these sinusoidal functions, is the C, the y-intercept. Your mean value here, you just go back to your function here. Your mean value should be this one. Your mean value should be this one. Okay, plus 3. Okay, my mistake, I wanted to select draw. Okay, your mean value is 3. Okay, Okay, then find voltage magnitude at t equal 0 seconds. Okay, that's number A. At t equal 0 seconds. Okay, what you will do, you will just use the same function, which is that one. Okay, let's write it down here. Okay, the function is f(v) of t, okay, equal 10 cos of 4 pi t minus pi over 3 plus 3, okay, volts. Therefore, at t equals 0, you will have 10 cos of 4 pi multiplied by 0 minus pi over 3 plus 3. Okay, you can punch everything on your calculator in radians. Do not forget to convert your calculator to radians. Okay, you have 10 cos 4 pi multiplied by 0 minus pi over 3 plus 3. Okay, therefore your answer here is 8. Okay, therefore your answer V at 0 equal 8 volts. Okay, 8 volts. Then number G, let's keep going. They say time when the voltage magnitude first reaches 8 volts. They say 5 marks, because we know earlier on we just found 8 volts here. You could just say t equals 0 here, but it is 5 marks, so we have to solve the problem. Let's determine general solution here, so we can have all the values of t and look at the t that comes first. Okay, then you'll have 8 on your left hand side, which is the voltage, equal 10 cos 4 pi t minus pi over 3 plus 3. Okay, therefore we have 10 cos 4 pi t minus pi over 3 equal 5. Okay, therefore you divide both sides by 10, you'll have cos 4 pi t minus pi over 3 equal 0.5. Okay, then from here you determine a reference angle. Okay, therefore you say angle ref equal arc cos. Okay, then you say 0.5 equal 0.5. Remember, we're using radians here. Equal pi over 3. Okay, radians. Fine, now you have the reference angle. Then we know that when you work with a Cartesian plane, a cosine function will be positive in this first quadrant and positive in this third quadrant, which is 2 pi minus theta. Okay, then now let's just consider first quadrant, because it's the one that can give us the first value where the function first reaches 8 volts. Okay, then you would have 4 pi t, okay, minus pi over 3 equal pi over 3. Okay, then you'll have 4 pi t equal pi over 3 plus pi over 3. Okay, therefore from here you can say t equal you can just say pi, but pi over 3 plus pi over 3 is literally 2 pi, okay, over 3 divided by by 4 pi. Therefore, your answer here should be 2 pi over 3 multiplied by 1 over 4 pi. Therefore, your answer here will be 2 over 12. Okay, therefore 2 over 12 is 1 over 6. Therefore your answer is 1 over 6 seconds. That's the first answer, like, of t that you got. Okay, then let's consider the other quadrant. Okay, let's consider the other quadrant. Therefore you will say, okay, we can do it on this side. Okay, you can do it on this side, and you say 4 pi t minus pi over 3, okay, equal, you're gonna say 2 pi, right, 2 pi minus pi over 3, the reference angle minus the reference angle. Okay, therefore you'll have 4 pi t equal 2 pi minus pi over 3 plus pi over 3. Okay, therefore from here you will have 4 pi t equal 4 pi t equal, okay, let me double check, equal 2 pi. Okay, therefore t equal 2 pi over 4 pi, which is 1 over 2 sec. I think I will have to double check this one as well. 1 over 2. I think we have to punch this on a calculator to double check, cos 4 pi multiplied by 1 over 2 minus pi over 3 should give us half. Yes, it gives us half. Okay, but between 1 over 6 and 1 over 2, which one comes first? This one equal, this one equal. 1 divided by 6 equal 0.17 sec. Okay? Then this one is 0.5 sec. Therefore this one will come first. So the correct answer for you here is 1 over 6 seconds. Okay, 1 over 6 seconds. So I think we are done with question 1. Then we can do question 2. We can do question 2 where they give us a function h of t. They say equal sine pi t plus root 3 cos pi t. Okay, let me write it down this on this side, then we continue with it. Okay, number 2a. Okay, you have a function h of t equal sine pi t plus root 3 cos pi t. Okay, this is engineering mathematics 1. Remember, engineering mathematics 1. So this question will express h of t in the form r cos pi t minus theta. Express h of t in this form, r cos, okay, pi t minus theta. Okay, we're going to start now. Okay, first we need to work out this r cos pi t minus theta. That's the first step you must do all the time. You're gonna say r cos pi t minus theta. Okay, this equal, you're gonna use the identities. You can use your formula sheet at the back of your question paper. This one, since it's a cos, it will be cos sin, but with opposite sign. Okay, then you'll have r cos pi t cos theta plus r sin pi t sin theta. Okay, then from here you can relate this expression you just formed to the original expression that was given. You can relate them. How so? Let's start with the first term. The first term has a cos. You're gonna say r cos pi t cos theta should equal root 3 cos pi t. You can see it is here. This one you must relate it to the one with cos here. Okay, you must relate it to the one with cos. Then now you need to determine the unknowns here. R theta and r are the ones that we are solving in this question so far. Here you will divide both sides by cos pi t, because it is common. Cos pi t, it is common, so then you will have r cos theta equal root 3. Okay, now let's relate the second term of this expression on the right hand side, this expression. Therefore you're gonna say r sin pi t sin theta, it equates to, on this expression, on this equation, it equates to sin pi t sin pi t. Okay, then here you can divide both sides by sin pi t sin pi t. Okay, therefore r sin theta equal 1. Okay, now you have two important equations. You have r cos theta equal root 3, r sin theta equal 1. Now let's continue. We're gonna first determine the theta. If you say, or when you say r sin theta over r cos theta, you will have 1 over root 3. Okay, we'll have 1 over root 3. Then from here you can say tan theta equal 1 over root 3. Therefore theta equal arctan 1 over root 3. Your answer here will be, okay, let's check whether we use radians, or if we're still using radians. You can see we're working with pi. So arctan, do not forget you are using radians here, root 3, 1 over root 3. Therefore your answer is pi over 6. Now let's determine the value of r. Okay, we still use the two equations that we have, which are this one, these ones. Okay, therefore here we're going to use this identity, cos squared theta plus sine squared theta equal 1. Okay, we're going to use this identity. Let's begin. There we have in brackets, you can just use the identity r cos theta all squared plus r sine theta all squared equal root 3. Remember, r r cos theta equal √3. Therefore, we're gonna put it this side. Then r sine theta equal 1. You can refer to those two equations which we are using. Okay, then from here you'll have r squared, okay, out as a common factor. Then you'll have cos squared theta plus sine squared theta, or in brackets here, and here you'll have your right hand side will equate to 4, because you know square, when you square this √3, you only get 3. Okay, then it's going to add to this one here. Therefore, the identity, with the result to the identity, you'll have r squared equal 4. This becomes 1. Okay, therefore here our r is the amplitude, right? We're going to take the positive value since we want the magnitude of the amplitude, right? Therefore your answer here will be 2. Now you can finally express h of t as r cos pi t minus theta. The question, let's go back to the question. Okay, therefore you will say 2 cos pi t minus pi over 6. That's your answer. Okay, that's our answer here. Okay, then let's continue. Sketch. I think this one of sketching, we can skip it. This one we can skip this one. We want to focus on more interesting questions. We can skip this one. Yeah, I think we can skip it. Okay, let's see. Okay, in fact, let's end the question here. We'll continue part 2 in the next video.